Graphing a quadratic equation. First of all, let's remember what a quadratic equation is. A quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where a, b, and c represent real numbers, and a can't equal 0 because we have to have that x squared term in order for it to be a quadratic equation. If it doesn't have that x squared term, if it was just bx plus c, it would be linear, and if it had a higher power, then it would be cubic or something higher than that. When we graph a quadratic equation, it looks like a U or a parabola, and it can either be opening up or it can be opening down. A parabola is also symmetric, so if we were to fold it in half, the two sides would match up. So let's talk about the parts of a parabola. Every parabola is said to have 4 parts. The vertex point, which is also called the turning point, is either the highest point or the lowest point depending on which way it opens. So the vertex is the only point that doesn't have a buddy to match up with. So if we look down at this first graph, here's the vertex point, and what I mean by buddy is if we have a point, say if this were 2 spaces away from that, it's called the axis of symmetry, or that midline, to the right, then it would have a buddy going 2 spaces to the left. So it's that way, you know, say if this were 3 spaces up here to the right, we would go 3 spaces to the left and get its buddy. So leading into that imaginary line there in the middle, right here, that is called the axis of symmetry. And every parabola has an axis of symmetry. Now all of these parabola that we're going to be talking about, these are vertical parabola that open up or down. And so every axis of symmetry is going to be a vertical line. And if you'll remember, every vertical line, the equation of a vertical line is going to be x equals some number. Well, in this case, for our parabola, the equation of the axis of symmetry is always going to be x equals whatever the x value of the vertex point is. So say, for example, if this parabola, if the vertex point were to be, well, just imagine this is 1, 2, 3, and then we're going to go up 1, 2. So the equation, or I'm sorry, my vertex point would be 3, 2. So that would make my axis of symmetry, the equation of my axis of symmetry, x equals whatever the x is. In this case, it's 3. So x equals 3 would be my equation of my axis of symmetry. The roots are the x-intercepts of the parabola, and parabola can have either 2, 1, or no roots. The first picture here, or the first graph, has 2 roots, or 2 x-intercepts. The middle picture, or the middle graph, has 1 root, or 1 x-intercept, and you'll see that the last one has no roots, or no x-intercepts. If we were solving this, those would have imaginary solutions in that last graph. And every parabola is going to have 1 y-intercept. The y-intercept is where the parabola crosses the y-axis. In this first graph, you'll see this is the y-intercept. In the second graph, this is the y-intercept. And in the third graph, we can't see the y-intercept, but because our parabola is slanted on both sides, it never goes straight up or straight down. It's always slanted. And so eventually it's going to cross the y-axis at some point, and that would be the y-intercept of the graph. So every parabola has 1 y-intercept, but it can have 2, 1, or no x-intercepts. So let's look at these graphs, and we're going to name the parts of the parabola in each graph. In the first graph, the coordinates of the vertex point. So remember, the vertex point is either the highest or the lowest point of the graph. Okay, so that's this point right here. And the coordinates of that point would be 1, -1. Is the vertex point a maximum or a minimum? So is that the lowest point of the graph or the highest point of the graph? It's the lowest point of the graph, so that would be a minimum. The value of the maximum or the minimum. So we're saying how low or how high does that go? So we're going to look at the y-axis, and the value of that minimum is -1. Okay, so in this first graph, how many roots or x-intercepts, remember roots mean x-intercepts, how many roots does the first graph have? It has 2 roots. Okay, so the coordinates of those roots, the first one would be 0, 0, and the second one is 2, 0. All right, well, remember every parabola has a y-intercept, so the y-intercept here would be right here, which was also an x-intercept, and the coordinates of that y-intercept is 0, 0. And then the equation of the axis of symmetry, remember it's always x equals, and then it's whatever the x value is in your vertex. So in this case, the x value of my vertex is 1, so the equation of my axis of symmetry is going to be x equals 1. Okay, now let's look at the second graph. The coordinates of the vertex point on this graph, here's my vertex point, is 1, 0. Okay, is that a maximum or a minimum? Again, this would be a minimum. What is the value of that maximum or minimum? So we're saying how high or how low does it go? It goes to 0 on the y-axis. Okay, and then the coordinates of the roots. How many roots does it have? It just has this 1 root, and so the coordinates of that root is 1, 0. The coordinates of the y-intercept, okay, so the y-intercept is where it crosses the y-axis, and that would be at 0, 1. And then the equation of the axis of symmetry, it always starts with x equals. Okay, so then we go back and look at the vertex. It's whatever the x is in the vertex, so it's x equals 1. All right, here's a third graph. The coordinates of the vertex on this graph right there. The coordinates of that vertex is 0, -1. Oh, I'm writing it in the wrong spot. Graph 3, 0, -1. Is that a maximum or a minimum? Okay, well this time it's a maximum because it's the highest point on the graph. The value of that maximum or minimum, and this is a maximum, so the value is at -1. That's the highest point that it goes to. Does it have any roots? No, this graph has no roots. It doesn't cross the x-axis. Okay, what about the y-intercept? Well, the place that it crosses the y-intercept is also the vertex. So it's at 0, -1. And then the equation of the axis of symmetry, what does it start with? X equals, and the x value in my vertex is 0. So x equals 0 would be the equation of my axis of symmetry. Now let's talk about graphing a quadratic equation. A quadratic equation in standard form looks like this. Y equals a times x minus h squared plus k. Well, just like in our ellipse and our hyperbola and our circle, h and k represent the vertex point of the parabola. So we can pull those values out when it's in this standard form to tell where our vertex is. Now, just like in the circle, the ellipse, and the hyperbola, in all three of those other equations, we have x minus h and y minus k in those other two types of equations. I know you know that and they're squared. The hyperbola has a minus sign in between this, the ellipse has a plus sign in between it, and they also have denominators down here. The circle doesn't have those denominators, but the thing that they all have in common in the hyperbola, the ellipse, and the circle is that it has that part of the equation there. So remember, because of the fact that we have these minus signs in the equation, in the formula, when we pull out the h and the k, we have to change the sign. Well, when we look at this equation of a quadratic, the only thing that's in parentheses is our h. And there's a negative sign in front of it. So when we pull out the h, we have to change the sign. But the k, it's just plus k, so we don't change the sign of the k. So just to help you remember, in all of these conic sections that we've dealt with, whatever's in parentheses, we're going to have to change the sign. If it's not in parentheses, we don't change the sign. So we change the sign of the h, we don't change the sign of the k for our vertex point. The next piece of information that we can get from this equation is we can determine whether our parabola opens up or down. If we look at a, which is the term that's in front of our parentheses, if it's positive, then that tells us that our parabola is going to open up. So it's going to look like this. If it's negative, then our parabola is going to open down. We can find the roots or the x-intercepts by substituting 0 in for y and solving the equation. And we can find the y-intercept by substituting 0 in for x into the equation and solving. So it's just like finding the x-intercepts and the y-intercepts in a linear equation. If you want to find the x-intercept, you plug in 0 for y. You want to find the y-intercept, you plug in 0 for x. And then we plot those points, the vertex point, the y-intercept, the x-intercepts, if they're real, into the parabola, and make sure that all of our points except for the vertex point has a buddy. Okay, so let's graph this quadratic equation in standard form. Okay, so we're going to go through and answer these questions. Does the parabola open upward or downward? So remember, we can look at A to determine whether it opens up or down. Since A is negative, that would be a -1, then we know that it opens downward. Okay, so then it says list the coordinates of the vertex point. Okay, so we're looking for h and k. Remember, h is this, and we have to change the sign, so it would be -3. And then k is this thing on the outside. We don't change the sign, so it would be 1. So that's my vertex, -3, 1. Is the vertex point a maximum or a minimum? Okay, so we know that we have a point. Let's go ahead and plot that point. -3, -3, 1. Okay, so that's this point here. Okay, and then we know that it opens downward. Okay, so we don't know exactly where my other points are, but we know that it's going to do like this. Okay, so if it opens downward, that makes my vertex point a maximum. Okay, so it's a maximum. The value of that maximum, if we go over to see where it how high it goes on the y-axis, it would be at 1. So the value of my maximum is a +1. Okay, so then it says to find the coordinate of the y-intercept. So remember, if we're looking for y, we're going to plug in 0 for x. Okay, so let me do that in the equation. Plug in 0 for x. Okay, so if I simplify this, I get, now that negative is on the outside of the parentheses, so that's negative 3 squared plus 1. Okay, so I'm squaring that 3. That negative isn't being squared, so it's negative 9 plus 1, which would give me y equals negative 8. Okay, so the coordinates of my y-intercept, I plugged in 0 for x, and I got out negative 8 for y. Okay, so 0, negative 8 would be down here. All right, so remember that we have buddies in our graph because our parabola is symmetric. And so if I were to picture that axis of symmetry that's going through my graph like this, I'm not sure if you can see that. Let me make that a little bigger. Okay, so if we have this axis of symmetry going through my graph, however far we have a point on one side of the equation, or one side of the axis of symmetry, we're going to have that same point going the same distance on the other side of the axis of symmetry. So my y-intercept right here, we went 1, 2, 3 spaces to the right. If I go 3 spaces to the left, I know that there's another point that same distance from the axis of symmetry. Okay, and then the coordinates of the roots where it's crossing the x-axis, I'm going to plug in 0 for y and solve for x. So to give myself a little room, I'm going to erase this right here. All right, and let's rewrite the equation and plug in 0 for y. Okay, so I have 0 equals negative x plus 3 squared plus 1. Okay, so I need to solve for x, and since in front of those parentheses I have that negative sign there, if I move my whole x plus 3 squared over to the other side, then it becomes positive. Okay, so that's what I'm going to do. I'm moving x plus 3 over to the other side of the equation, and it makes it positive, and then the 1 is on the other side of the equation. Okay, so this can be solved by using the square root method. All right, so the square root method just says I can take the square root of both sides of the equation to undo that square. But remember, when we're taking the square root of a number, we have to put plus or minus in front. So the square and the square root cancel each other out, and I just have x plus 3 equals, the square root of 1 is 1, but that's plus or minus 1. Okay, so then I'm going to subtract 3 from both sides. Now I have to work this out twice. This is x equals, I have a positive 1 minus 3, which would be negative 2. And then I also have x equals negative 1 minus 3, which would be negative 4. Okay, so those two roots, the coordinates of my roots would be negative 2, 0, and negative 4, 0. Let me plot those points. Negative 2, 0. Oh, that wasn't 2. Negative 2, 0. And negative 4, 0. Okay, so now if I connect my points, I have my graph of my parabola. All right, there's a couple more questions. Write the equation of the axis of symmetry. So the axis of symmetry is that green imaginary line that I have drawn through the graph. And the equation of that, remember, it always starts with x equals, and it's whatever the x value in my vertex is, which is negative 3. Okay, the domain of every parabola that's a vertical parabola that's either opening up or down, the domain is always going to be from negative infinity to positive infinity, because our parabolas, remember, they keep going wider and wider, whether they're opening up or down. They're not going straight up and down, so they're slanted. So if we continue to travel in those directions, it's going to go from negative infinity to positive infinity. And if we're writing that in interval notation, Remember that we use parentheses for infinities. And remember, the domain is how far it goes left and right on the x-axis. Now the range is how far up and down it goes. Okay, so our range in a parabola is going to go towards either negative or positive infinity, but it's going to have a stopping point because it has a maximum or a minimum value. So in this case, our range, we always go from smallest to largest. So if we look down at the bottom, it's going to negative infinity. And then if we travel up to the top, the highest point in our graph is, remember, for our range, we're just looking at the y values. So it goes up to 1, and since it crosses through that point is included. So if I had a parabola, say, that opened the other direction, if it opened up, say if we had a parabola that went like this. Oh, well, I was trying to make it stop on a certain number. Let's do it like that. Okay, so the domain of this parabola would be negative to positive infinity, just like all of them. But the range for this one would start at 0 and go to positive infinity. Now we're going to graph a quadratic equation that's in general form. So general form is what we looked at the very beginning. Y is equal to ax squared plus bx plus c. Just like the equation of a parabola in standard form, a still tells us the direction that our parabola opens. If a is positive, then our parabola is going to open up. If it's negative, then it's going to open down. The difference between the two forms, however, is how we find the vertex. In standard form, we could just pull out our h and our k. But it's not quite that simple whenever it's in general form. When it's in general form, to find the x value of our vertex, or our h, then we are going to use this little formula here. Negative b divided by 2a. And then to find our k, or our y, value of our vertex, then we just take that value and plug it into the equation where the x is and solve it to find our y. And then we find the roots and the y-intercept just the same as before. If we want to find the x intercepts or our roots, we plug in 0 for y. If we want to find our y-intercept, we plug in 0 for x. And then we plot our points to graph our parabola. Okay, so here is the quadratic equation. First of all, does the parabola open up or down? So remember, a is whatever the coefficient of that x squared term is. Since that would be an understood positive 1, we know that it opens upward. Okay, so now we need to find the coordinates of the vertex point. So remember, to find our h, it's negative b over 2a. Okay, so what is b in this equation? B is 4, so this would be negative 4 over 2, and we said that a was 1. Okay, so that's just negative 4 divided by 2, which is negative 2. Okay, so we know that's h, or the x coordinate of our vertex point, so negative 2. Now we have to find out what our k is, or our y value. Okay, so I got to give myself a little room here. Okay, so I just take that negative 2 and I'm going to plug it into the equation every place that I see an x. So this would be y equals negative 2 squared plus 4 times negative 2 minus 5. Okay, so when I square that negative 2, so this time I plugged in negative 2 for x, so the whole thing is being squared. So negative 2 squared would be positive 4. And then 4 times negative 2, that would be minus 8 minus 5. All right, so 4 minus 8 is negative 4 minus 5, which would be negative 9. Okay. So negative 2, negative 9 would be my vertex point, which is right here on the graph. All right, is that vertex point a maximum or a minimum? Okay, so since we know that our parabola is opening upward, that vertex point is going to be a minimum. So the value of that minimum, if we carry it over to our y-intercept, is going to be at -9. Okay, and then the coordinate of the y-intercept, okay, so remember to find the y-intercept, we plug in 0 for x. Okay, so I'm just going to plug in 0 every place there's an x in the equation. So those first two terms just turn to a 0, and I get y equals -5. So my y-intercept is 0, -5. Okay, let me plot that point, 0, -5. And then remember it has a buddy on the other side of the axis of symmetry. So that point, the y-intercept was 2 spaces to the right. I'm going to go 2 spaces to the left of the axis of symmetry. So now to find the roots, I'm going to plug in 0 for y and solve for x. Alright, so I'm going to see in a quadratic equation, you know there's different ways to solve a quadratic equation. Factoring is the easiest way. We used the square root method before whenever it was in standard form, but I'm going to see if this factors. Okay, so if I have x and x, this is a trinomial. The only factors of 5 are 5 and 1. I know that my signs are different, and the biggest one needs to be positive. And so that does factor. Remember, we can check it by doing the smiley face. That's a positive 5x and a negative 1x, which gives me a positive 4x, and that's what my middle term needed to be. Okay, so I know that it factored correctly. Once I factor it, I'm going to take each factor and set it equal to 0 and solve. Okay, I don't need that parenthesis. X plus 5 equals 0, and x minus 1 equals 0. If I solve this, I get x equals -5 and x equals +1. So my roots would be -5, 0, and 1, 0. Alright, let me plot those points. 1 and -5. And then if I connect those points, I have my parabola. It's not the prettiest parabola, but it's a parabola. Alright. Okay, the equation of the axis of symmetry is going to be x equals whatever my x value of my vertex is, and that would be -2. The domain of all of our parabolas are -infinity to +infinity. The range, we start from the bottom and go to the top. So the lowest point on our graph is at -9, and that's included, and it goes up to infinity. Okay, so all of the things that we've talked about in Chapter 7 are called conic sections. Conic sections are just if we were to take a cone and cut it in some way, we would get one of the things that we talked about. So if you see, if we take a cone and we were to just slice it horizontally, then we get a circle. If we were to slice it at a little bit of a diagonal, like we're doing here, then we would get an ellipse. If we were to just take one of the cones and slice it up close to the top, like we're doing here, that would make a parabola. And then if we were to do a perpendicular cut, like here, then we would get the hyperbolas. So now that we have covered all the different conic sections, you should be able to look at an equation and determine what kind of, or what the graph would look like. So let's look at number 1. This is x plus y. I have an x and a y, and there are no powers. So if we don't have any powers, then we know that this would be the graph of a diagonal line. All right, in number 2, we have an x and a y, and they're both squared. There are no denominators, so this would be the graph of a circle. All right, number 3, we have an x and a y. The x is squared, but the y is not, so only one term is squared. That would be a parabola. Okay, number 4, we only have a y, and it's not squared. So if you remember IV.Graphing, that would be the graph of a horizontal line. Okay, number 5, our x and our y are both squared and they have denominators. So since we have these fractions in here, we know that it's going to either be a parabola, an ellipse or a hyperbola. So remember, to tell the difference, we look at what they're connected by. So if it's connected with a plus, then that means that it's an ellipse. Okay, so number 6 looks like number 5, except for it's connected with a minus sign, so this is a hyperbola. And then, last but not least, we have x equals 36, so it's just an x, not an x and a y. And since it's not squared, we know that it's a line, but IV.Graphing, we know that it's a vertical line. And that's how we determine what our graphs look like.